Now that we've taken a look at the structures involved in breathing, let's talk a little bit about the physiology of how we actually breathe. So first of all, the term breathing is more officially known as pulmonary ventilation. So this is just the act of air entering and leaving the lungs. Inspiration is another word for inhalation, which means air enters the lungs. And expiration is another word for exhalation, which is air leaving the lungs. Now, the thing that causes the air to move in and out of the lungs is due to differences in pressure between the lungs and the atmosphere. So we're going to take a look at pressure and how pressure and volume are related. So first of all, volume and pressure are inversely related. So if we take a look at a container has a volume, and a volume is just an amount that the container can hold, or it's the size of the container. And then we've got molecules inside this container, and these molecules are bouncing around. So let's pretend like these molecules are oxygen or carbon dioxide, or really just air in general, which is a mixture of different gases like oxygen, carbon dioxide, nitrogen, etc. Now, if we keep the number of molecules the same, let me see if I can get my cursor back. There we go. If we keep the number of molecules the same, but we decrease the volume, now those molecules are more compressed. And so by decreasing the volume, we have increased the pressure. Now this can also work in the opposite direction, where if we keep the same number of air molecules, but we increase the volume, it will decrease the pressure. So keep this in mind. Think about the container as being a lung, and the molecules inside of it are the air molecules that you breathe in and breathe out. All right, so first of all, there is pressure in the atmosphere. So atmospheric pressure is just the pressure of the air pushing in on you. So you probably don't notice it just in day to day, because the air pressure stays relatively relatively stable. It does change a bit with weather changes. Also elevation and altitude will alter it a bit as well. So it's the greatest at sea level, and then it decreases as you go up in elevation or up in altitude. But in a given area, it's relatively constant, so you probably don't notice big changes in the atmosphere. You might be more familiar with atmospheric changes if you've ever been in an airplane. When you go up in an airplane, the atmosphere is, the pressure of the atmosphere is less than it is when you're on the ground, and that's what causes you to have to pop your ears when you're in an airplane. Now, airplanes are pressurized, but they're not pressurized all the way to what they would be at sea level. So that's why you get the pressure changes and your ears pop, and sometimes you get a headache. All right, so there's the pressure that is out in the atmosphere, and then you also have pressure within your lungs. And this is called the intrapulmonary or intraalveolar pressure. All right, so this is the air inside the lungs, and these air molecules are bouncing around. They're exerting pressure on the inside of the lungs. Now, the lungs change volume, they change shape and volume, which changes the pressure in the lung. All right, so now that we've covered atmospheric pressure and intrapulmonary pressure, now we can take a look at how those pressures are involved in allowing for the movement of air in and out of our lungs. Now, some people think that the air is pushed into our lungs, but you can really think of it more as the lungs are sucking air into the body. So think of your lungs as kind of like vacuum cleaners. So a vacuum cleaner is something that it can suck. And so your lungs are sucking air into them because the lungs are changing volume, which changes pressure. So let's start out with looking at how we take an inhalation, or how we inhale and take in air. So the first thing that happens, notice we're not going to start with any air moving because we have to change the pressure before the air can move. So the first thing that happens is that the muscles involved in inspiration or inhalation contract. The primary muscles involved in inhalation include the diaphragm, which is this flat muscle that makes up the boundary between the thoracic and abdominal cavities. And then you also have external intercostal muscles. And these are the muscles that are kind of superficial, located in between the ribs. So as these muscles contract, it pulls the rib cage up and open, and the diaphragm flattens out. And the result of these muscles contracting is that the volume of the thoracic cavity increases. All right, now remember that the lungs are stuck to the inside of the rib cage by the pleural cavity, the pleural membrane, so the serous membrane of the lungs. And so when the rib cage expands, it pulls the lungs open. So remember our relationship between volume and pressure. So we've got our thoracic cavity is increasing in volume, which is pulling our lungs open so that they also increase in volume. Now when volume increases, pressure decreases. So any residual air that is still in the lungs from the last time you breathed is still there, but now we've increased the volume, which is going to decrease the pressure. And air moves along your pressure gradient. So air is going to move from an area where there is higher pressure to an area where there is lower pressure. So when the pressure inside the lungs, so the intrapulmonary pressure, drops to that of below atmospheric pressure, air is going to move into the lungs. So remember that the atmosphere is not pushing air into your lungs. Instead, your lungs are increasing in volume and decreasing in pressure, and then sucking that air into the lungs. So the air is going to move into the lungs when intrapulmonary pressure is less than atmospheric pressure, which is the pressure out here. Now, exhalation happens pretty much in the opposite way. So the respiratory muscles relax. So the diaphragm relaxes and the external intercostal muscles relax. And you can probably guess what happens next. When those relax, the thoracic cavity gets smaller. So the volume of the thoracic cavity gets smaller, and the lungs are stuck to the inside of the rib cage. So the intrapulmonary volume also decreases. And we know that volume and pressure are inversely related. So as intrapulmonary volume decreases, our intrapulmonary pressure is then going to increase. And just like air moved down its pressure gradient during inhalation to bring air into the lungs, when the intrapulmonary pressure raises to above that of atmospheric pressure, then the air is going to move out of the lungs and into the environment. All right, so once again, the movement of air is not what starts or stops an exhalation. It's actually the thoracic cavity changing volume because of the rib cage changing size, and because of those inspiratory muscles either contracting or relaxing. And the volume changes cause pressure changes, and then when the pressures are unequal, air will flow in the direction to try to equal them out.